Good morning, students. In class, we have started chapter number 4, Chemical Thermodynamics. Already we have learned some of its topics. Today we'll start enthalpies of physical transformations. In that, first it is fusion. What do you mean by fusion? Conversion of solid into its liquid is known as fusion. Let's consider H2O solid, that is we'll call it as ice, converts into H2O liquid. So in this process, whatever is the enthalpy change, it is known as enthalpy of fusion. How do we define it? Enthalpy change that occurs when 1 mole of a solid is converted into its liquid without change in its temperature at constant pressure is known as enthalpy of fusion. So H2O solid converts into H2O liquid. Delta H is nothing but enthalpy. This is for fusion. So we'll call it as delta H fusion is equal to plus 6.01 kilojoule per mole. Okay, and we know that here 1 mole of solid ice, when it melts at 0 degrees Celsius at that time and 1 atmospheric pressure, then change in enthalpy is equal to 6.01 kilojoule. Opposite to that, when H2O liquid, that is water in a liquid state, converts or it solidifies, this process is known as freezing. So delta H freezing is equal to minus 6.01 kilojoule per mole. That means here fusion is endothermic reaction while freezing is exothermic reaction. This much amount of heat is evolved during the process. Second is enthalpy of vaporization. Enthalpy of vaporization. What do you mean by vaporization? Vaporization is nothing but conversion of liquid into its gas. So enthalpy change for the conversion of 1 mole of liquid into its vapor at constant temperature and pressure is known as enthalpy of vaporization. Here at 100 degrees Celsius, its value is equal to plus 440 kilojoule per mole. An opposite process or the reverse process, that is conversion of gas into its liquid, is known as condensation process. And enthalpy change associated with it is equal to minus 40 kilojoule per mole. Now, third physical transformation is conversion of solid directly into its gas, and the process is known as sublimation. So, enthalpy of sublimation. We have seen camphor. In Marathi, we'll call it as kapur. When it burns, at that time, it converts from solid state to directly into the gaseous state. Here we have learned example of conversion of H2O in solid state directly into the gaseous state. So enthalpy of sublimation is enthalpy change for conversion of 1 mole of solid directly into gas at constant temperature and pressure. Here delta H of sublimation is equal to 51.08 kilojoule per mole. So we can say that enthalpy of sublimation is sum of enthalpy of fusion and enthalpy of vaporization. Okay. After that, we'll learn enthalpy for atomic or molecular changes. In that, first is enthalpy of ionization. What do you mean by ionization? Do you remember redox reactions? In that, atomic, for example, this is sodium. Sodium in a gaseous state, when it converts into its ion, positively charged ion, at that time, one electron is lost and we'll get cation. So, enthalpy of ionization is the enthalpy change during conversion of atom into its ion. And how it is there? By removal of electron. So again, we'll define enthalpy of ionization is the enthalpy change. Here delta H ionization is equal to 494 kilojoule per mole. So enthalpy of ionization is the enthalpy change accompanying the removal of an electron from 1 mole of gaseous atom. And during the process, positively charged ion, that is cation, is formed. Okay. Now, next it is, we'll see conversion of atom into its negatively charged ion. For example, chlorine. We know that 287. Okay, in order to attain stability, it gains 1 electron. It converts from Cl atomic state into Cl minus, that is anion. So here electron is gained. This is loss of electron and this is gain of electron. So this is known as electron gain enthalpy. So electron gain enthalpy, it is the enthalpy change when 1 mole of gas phase atom of an element, it accepts an electron and to form gaseous anion. So Cl gas plus electron gives Cl minus in a gaseous state, and delta H, that is enthalpy associated with this electron gain, it is equal to minus 349 kilojoule per mole. Okay. Now, next it is enthalpy of atomization. This is electron gain enthalpy. Now, enthalpy of atomization. Atomization means formation of atoms, like Cl2 gas converts into 2Cl atoms. Okay. So, enthalpy change accompanying the dissociation of 1 mole of gaseous molecule into its atoms. It is known as enthalpy of atomization. And here delta H atomization is equal to 242 kilojoule per mole. Okay, so Cl2 gas converts into 2Cl atoms. And during this is the enthalpy change. Now we'll see enthalpy of solution. Next is enthalpy of solution. For example, we have NaCl in a solid state. Okay. When we add water in it, sufficient amount of water is added into it, then that is water as a solvent, then we'll get NaCl aqueous. Why the word aqueous is there? Here water is used as a solvent. So whatever enthalpy change associated with that, it is known as enthalpy of solution. And its value, it is 4 kilojoule per mole. So we'll define enthalpy of solution as it is the enthalpy change in a process when 1 mole of a substance is dissolved in specified amount of solvent. So formation of solid or conversion of solid into its aqueous solution, it is known as enthalpy, or an enthalpy associated with that is nothing but enthalpy of solution. Okay. One more is there, enthalpy of combustion. What is combustion process? Combustion, it is nothing but reaction of a substance with, for example, we'll say CH4, methane. Substance reacts with oxygen, it converts into carbon dioxide and water. So this is in a gaseous state, water is in a liquid state. How to balance? 1 carbon atom here, 1 carbon dioxide, 4 hydrogen atoms, so you will write 2 H2O. Now count oxygen on the product side, 2 plus 2, 4. There is no oxygen in this molecular formula of a substance, so that's why we'll directly write here 2 H2O. Okay, so this process, that is substance reacts with oxygen in the air and it converts to its carbon into carbon dioxide and water. This process is known as combustion process, and enthalpy change associated with that, it is known as enthalpy of combustion. Here delta H is equal to 809 minus 890 kilojoule per mole. So we have learned certain physical transformations as well as here molecular or transformations. Okay. So in this way, we have learned many types of processes and enthalpy change associated with that. Whenever we'll solve problems on Hess's law of constant heat summation, you will require all these things. Okay. Thank you.